So let's continue discussing the new aspects of clouds which distinguish them from previous generations of distributed computing systems. We discussed massive scale in the last lecture. Today we move on to the second aspect, which is the on-demand access, and we'll discuss here as a part of this the AAS classification that is popular in industry. So on-demand access basically means that you pay for exactly what you use rather than paying an upfront cost or buying something upfront. This is sort of like renting a cab versus what used to be previously renting a car, where you might have to pay some upfront cost for to use servers that others own, or buying a car, which essentially is analogous to buying your own data center. Instead, today's services allow you to pay a few cents to a few dollars per CPU hour, and you can use as many CPUs as you want, as your application needs. For instance, this is what AWS EC2 as well as Microsoft Azure provide for you. Or you can pay a few cents to a few dollars per gigabyte month that you store. Once again, AWS and Azure provide these services for you. And there's a variety of other companies providing similar services for you at competitive rates. Now, in industry, there is often a classification of the cloud services that are provided based on the nature of the services themselves. These are often classified as an AAS classification, or as a service. So HAS stands for hardware as a service. Essentially, this means that you get access to the bare bones hardware machines and you can do whatever you want with them. For instance, if you buy your own cluster, your own private cloud, then you're running a hardware as a service. But exposing a hardware as a service to other users, especially those that you don't trust, may not be a good idea because of the security risks involved with giving root access on your machines to untrusted users. Infrastructure as a service allows you to get access to machines and install your own operating systems and machines, but without having the security holes of the hardware as a service. Essentially, this uses virtualization so that you can spawn up your own VMs and instances. And essentially, AWS, Microsoft Azure, and a variety of other players offer services that are infrastructure as a service. And this is one of the most popular ways of using public clouds today. Oftentimes, this is said to subsume HAS. The knowledge of these terms in industry is not uniform. There are conflicting definitions, but you might often hear that IaaS subsumes hardware as a service. There are two other classifications. Platform as a service essentially is a more of a tightly congealed or consolidated service form of IaaS. You don't get access to VMs, but you write your code, and it's tightly integrated with the software platform. For instance, Google's App Engine allows you to write code in Python, Java, or Go, and then it auto scales out your application depending on the incoming load. But you don't necessarily think about VMs at that point of time, and you don't necessarily need to think about installing VMs or provisioning VMs. A lot of the provisioning is done for you. So it's easier, but it is less flexible than IaaS. Finally, you have software as a service, and essentially this gives you access to software services when you need them, and again, you pay on demand. This includes Google Docs, which I'm sure a lot of you have used, and also Microsoft Office on Demand, and many others that are out there. Service-oriented architectures, which have been popular for many decades, are often said to be subsumed under the software as a service. So SaaS as a definition is a little bit broader than what I've talked about on this slide, because it also includes the SOA architectures. The third aspect that is new in clouds today that distinguishes it from previous generations of distributed systems is that we are dealing with large amounts of data. And so previously, while there was computation-intensive computing, for instance, the message passing interface or MPI-based computing, and high-performance computing, where you would have a relatively small amount of data, but you'd run fairly intense computations on it. For instance, weather modeling is a computation-intensive computation. And this includes, of course, data centers such as NCSA Blue Waters. But data-intensive computing is sort of the reverse, where you have large amounts of data that are stored at data centers, and you need to use compute nodes that are nearby, just because you're dealing with enormous amounts of data, petabytes or terabytes or exabytes. And these computation nodes run computation services that allow you to process the data. So the shift in computation-intensive computing toward data-intensive computing is a shift away from computation to the data. You need to pay more attention to the data. You need to bring compute cycles closer to the data. And then when you look at the servers themselves, CPU utilization, which used to be the main metric for measuring resource utilization in computation-intensive clouds, is no longer the most important metric. Instead, I/O is. This includes disk I/O and also network I/O. Oftentimes in data centers, you will find that the disk or the network I/O is close to being maximized out, while in computation-intensive clouds, the CPU utilization is going to be fairly high. Once again, this is not a hard and fast rule. After all, data centers are just very super large clusters, and so you can use them to run both computation-intensive jobs as well as data-intensive jobs. Finally, you have new cloud programming paradigms. This includes ways in which you can process the data, which tend to be the bulk of the new cloud programming paradigms, and also ways in which you can store and query the data fairly quickly. Google introduced MapReduce as well as other engines like Sazal, and these were open sourced, or rather open source versions were written of these by Yahoo. That became Hadoop. It was later open sourced, and it is now an Apache project. It has also been spun off as a separate company by Yahoo as of this date. MapReduce itself is offered as an Elastic MapReduce service on Amazon, again as you pay as you go as you process your data. And MapReduce is useful for processing very large amounts of data. For instance, companies use it to process a lot of the data that is part of their core mission. So for instance, Google, of course, Google is known for its search engine, but in order to provide results to you in the search engine, they need to index the data, the websites that are crawled by their crawlers. This indexing in 2006 was done by a chain of 24 MapReduce jobs. It processed about 50 petabytes per month, and it was using 200,000 MapReduce jobs. Yahoo similarly has a web map application, which is a chain of 100 MapReduce jobs. It processed 280 terabytes of data in 73 hours when you use 2,500 nodes. There's also another engine there called Pig, which is developed on top of Hadoop. Facebook uses Hadoop as well as another engine called Hive, developed on top of Hadoop. And once again, they were processing 55 terabytes per day and adding 2 terabytes per day back in 2008. And there's a variety of other companies that use MapReduce to process their data sets and the daily logs, including companies like eHarmony.com, which actually use it to do overnight runs where they match dates with each other. Essentially, that's a MapReduce job. So that's computation. There's also new cloud programming paradigms where you can store and query data fairly quickly. MySQL is an industry standard, but NoSQL and key value store systems, which are the new cloud storage systems, are many orders of magnitude faster, and you'll see why as we go along later on in the course.